Welcome. I made this video to try and clear up some of the questions that we had today on number 2 that we were looking at on that homework. And I encourage you to not view this video as sort of exactly how to solve problems like number 2, but instead let it be an opportunity where we can kind of step back and observe how some of the theoretical concepts of the course are interacting with each other. So I've chosen the presentation in this video so that it might try to connect some of the points in this course. So imagine I had this problem for you, and I said, here's a function, f of x is sine of 2x, and I wanted to know what is f prime at 7. Do you think we could solve this problem? Do you think we could do this? And now might be a good time actually to pause the video and try to solve this. It's totally something you can do. It could be one of the web work problems. The point is, yeah, we're gonna use the chain rule. So the chain rule says that the derivative of sine of 2x is going to be cosine of 2x, and then we multiply by 2, right? We multiply by the derivative of that inside function there. And then that's a formula for the derivative, that's f prime of x. And if we want to know f prime at 7, then I guess we're just going to plug in a 7. So we're going to get cosine of 14 times 2, and I pulled out a calculator and I got 0.273. Right? So that's really good. And so let's record that. Right? So if our function is sine of 2x, then f prime of 7 is 0.273. So now let's step back and go back a little bit in time and imagine that I had asked you to try and compute this derivative the first week that we were doing this. If I said, suppose that f of x is sine of 2x, and I said, what is f prime of 7? Well, we didn't know the chain rule back then. We didn't even know the power rule. The only thing we knew was the definition. And so what we knew was that f prime of 7 is going to be the limit as x goes to 7 of this expression. As we're preparing for the exam now, you may want to review this definition. This is definition you might need to use on the exam. And we say, oh, well, I know what f of x is. The problem says that f of x is sine of 2x. F of 7, I plug in 7. That's going to be sine of 14. And I can simplify this a little bit. But, I mean, you could try sort of computing this limit, but we're a little bit stuck, right? We actually didn't learn any methods about limits for how to deal with trig functions like this, right? We could try plugging in x equals 7. We're going to get 0 over 0. We're kind of stuck. We don't really know what to do, and we're kind of in this problem. Well, if the first week of class we wanted to find f prime of 7, I don't know, we'd write down this limit and we would say, I don't know, it's a mystery, right? At least I don't know how to compute this limit just using some of the techniques we've learned in the course. Right? I don't know how to do it just thinking of it as a limit. But now, I don't know, let me give you a recap. See if this makes any sense. So we saw that our function, if the function's sine of 2x, then we know 100% that f prime of 7 is 0.273. So if I were to say what's the derivative evaluated at 7 of this function, we already did that. That was the first problem we did, and we used the chain rule and we got 0.27. Life was great. And now down here, well, I don't know, I have this question. Can you figure out what the mystery is? Well, I've got my mystery in a box, and I know it's this limit, but I don't know, but I just got through saying I don't know, it's maybe a tricky limit, how do we do it? But wait a minute, this mystery, yeah, it's this hard limit I don't know how to do, but this mystery value, it's equal to f prime of 7, isn't it? That's what this whole line is saying. So our mystery value, wait a minute, shouldn't it be 0.273? Yes, it should. Because these two things are measuring exactly the same thing. And so by computing the derivative in two different ways. One, by using the chain rule, which is definitely the right way to solve this problem. It's very quick. Um, we've actually gotten some information about a limit. And so now let's put this to use by solving it in a similar way to how it's phrased on that homework. So deep breath. We can all use a deep breath. Maybe after this video, I'll go and watch a meditation video to breathe deeply myself. But let's get ready. Suppose the problem was like on the worksheet. Suppose we were just given a limit like this. And it said, what's the limit as x goes to 3 of x to the 5th minus 3 to the 5th over x minus 3? Can we figure out what that mystery is? Well, I would sort of look back and I would say, well, wait a minute. This totally looks like the derivative of some function. Right? Doesn't it look like f of x minus f of 3 over x minus 3? Right? And we take the limit as x goes to 3. That's going to be the derivative of some function evaluated at 3. Right? And so, well, I don't know, we could try and factor this problem and try to do something like that. But why don't we notice that this mystery function is just the derivative of some function at 3? And what is that function? Well, it's not sine of 2x. It's x to the 5th. Right? And we can see that because what's our formula? Well, we have x to the 5th minus 3 to the 5th. So it looks like our function is going to be x to the 5th. And so now we have just one step left. If we want to find f prime of 3, well, why don't we can just use the product rule. So we step back here, we say our function is x to the 5th. That means its derivative should be 5x to the 4th. And so if I want the derivative evaluated at 3, I'm just going to plug in 3 to this formula. So that's what I did. I did 5 times 3 to the 4th, and I got 405. And so that's the answer. That's going to be the mystery. And so as you, I encourage you to go back and look at the question on the homework. And it's unlike anything you've seen before. It's something new. And it probably felt challenging. It might feel like it's really stretching conceptually what we're doing. That's okay. That's why we went through it in class. That's why we're making this video. And now you can go back and practice that again. There's a web work question that allows you to practice this concept as well. And that's so we can be prepared when this problem may come up in the future. So thank you for watching, and I will see you soon. Bye.